Now, realistically, when we're looking at a set of data, we're not usually going to look at just like 5 or 10 or 20 pieces of data. We're going to look at like a large scale of data, and that's where these frequency tables are really helpful. Okay, and often we do group things into frequency tables because they tend to kind of draw things in a little bit closer and make things a little bit easier to help us with, and to make it a little easier to understand our what our data looks like. Now, you'll notice, remember with a frequency table, we're going to put in the mean mark or the mean value of it. So in this case here, we have like groups of 80 to 95, sorry, 80 to 90. The average would be 85. 90 to 100 is 95. So we're going to put this mark in, and we're going to put it this many times. Okay. The data loses its individuality, as all the data is often grouped, but it does give it a little bit of a simpler way of putting data into a spreadsheet. So what you can do is we can use that spreadsheet to find the mean, median, and mode. Now, we've done that in the past, and I'll let you kind of do that again on your own. I'm going to just jump into right away showing you how to determine if something is normally distributed. Okay. Our mean, in this case here, and this is what I've calculated already ahead of time, is 122.2, and our standard deviation is 20.69. Okay, so 20.69 is our standard deviation. So it's nice to have these, and then we know kind of where we stand on certain aspects. Here's our graph that we're going to put in, and we're going to create a histogram using the data that we have. Now you'll notice I have my title, frequency on the left, and my IQ is on the right. We're dealing with IQ in this case here. Here's the frequency going up the side. The highest one is 20, so I just need to make sure that I have at least 20. And then on the bottom, I have all my groupings, so 80, 90, 100, so all of those gaps. Now we draw in our rectangles. And so I'm going to start with 80 to 90, and there was 8 of them, 8 people that need a square or a rectangle here. Okay, so let's try this again. So we have 8 right there. Okay, and then the next one between 90 and 100, there was 9 people that were in there. So this was an IQ test that we were doing, and we're trying to see, is it normally distributed, or at least is this group of people normally distributed when it comes to it. You'll notice right off the bat, okay, this was 10. So we have 8, 9, 10, and then 20. You'll notice right from the beginning, we're going up very slowly with these ones here. By the time we get here, we should be a lot higher, to be very honest. We should be a lot higher, and it does come right here between 110 and 120. We get our big one of 20. Okay, so there's our big one of 20. And then between 120 and 130, we have 18. So it looks good that kind of in our middle, we have a lot. That's a good thing. That's what we want. And I'm going to have to tweak all of these in a little bit yet. Here we have another 11. Or here we have 11. And then just want to double check my numbers here, 12 and 12. So the next two are exactly the same. So 12, and go back to yellow, and 12. Okay. You will notice with this group of data here that in fact, okay, and as I fill in all of them, it's going to be a little easier to see as well. This does not look normally distributed. Firstly, by the end, it's kind of going up again. Okay, so you'll notice that by the end, it's going up. So those last ones, we have numbers going up. We're going up to, in this case, it's up to 12, which is much higher, is even higher than the one before it. Okay, we're not like the middle is the highest, but it's also not overly, it's not overly distinct. Okay, and it should be overly distinct for it to be considered normal. Okay, so we need to have a really distinct bell curve in here. Paint that last one there. just make this, there we go, it looks a little bit better. This should all be connected. So this does not look like a normal curve. We have this high spike in the middle, but then like the rest of them are kind of going up. We should be like really low to start and really low to end, and then a nice bell curve in there. So this probably tells us that we are not normally distributed. Okay, there's a good chance that we're probably not normally distributed. Now, if we look at our other two criteria, and I'm going to put them here on the side. The first criteria is that half the data should be below the mean. Okay, so number one, half the data should be below the mean. Our mean is 122, so that's right here. So we have 8 plus 9 plus 10 plus 20 is 47 out of 100, which is equal to 47%. To be very honest, that's actually inside of our range that we're looking at. That's saying that, yeah, we could actually do that. So this one checks out. Okay, that one checks out. We're good with our first one, 47%. We can deal with that. That can be, that's close enough to consider it normal. The second one here, okay, we need to be within 1 standard deviation. So that is 122.2 minus 20.69. And so this is, let's see, 122.2 minus 20.69. We have 101.51 right here. So between 101.51 and 122.2 plus 20.69 is 122.2 plus 20.69, 142.89. So again, we're going to be between like, well, even if we use our averages, okay, we're going to be the 105 to the 135. So we have 10, 20, 18, and 19. So that's 30 and 29, and so that's 59. So because of that, so that would be 59 out of the 100, which is 59%. Okay, that is definitely below what we would recommend, or definitely below what we would expect. So therefore, this one does not match. Okay, so this is less than the 63%. That's kind of our low end. We said 68, 63 is our low end. 59% is definitely below that. So that means that we do not have enough data points inside of that gap. And I'm just going to quickly circle. So we were looking at these ones right here for being inside of 1 standard deviation. Okay, there's just not enough. There's too much outside to consider this normal.